Hey guys, tonight we're embarking on a journey not through ancient lands, but through the even more ancient, mysterious landscape of sleep. Close your eyes for a moment. Feel the quiet hush of the world settling around you, the gentle pull of drowsiness. It's a sensation so familiar, so fundamental. Yet have you ever stopped to think about why we do it? Why does half of our life, sometimes more, get spent in this seemingly unproductive state? It feels so natural, so necessary, that it's hard to imagine existing without it. But sleep, in its myriad forms, has been evolving for hundreds of millions of years, a constant, vital companion to life itself. And frankly, if you didn't have to sleep, you'd probably be a lot more productive, but definitely a lot less sane. Just imagine the sheer chaos of a permanently awake world. It's enough to make you crave a nap right now. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you're up for it, drop a comment with your location and what time it is for you right now. I always love seeing how far and wide our sleepy community stretches. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You begin to settle, letting your thoughts drift. The concept of sleep often conjures images of cozy beds and quiet rooms, but its origins are far more primal, far more ancient. We're talking about a biological imperative that predates almost everything else we consider essential for complex life. The very first hint of something akin to sleep, a period of reduced activity and responsiveness, likely appeared with the earliest complex organisms. This is a mainstream biological fact. Sleep, or at least a sleep-like state, is an evolutionary ancient phenomenon, observed in almost all animals studied, suggesting its deep-rooted importance for survival. It's not just a human quirk, it's a fundamental feature of life. Imagine being one of the earliest multicelled creatures, perhaps a simple jellyfish or a primitive worm. You're constantly seeking food, avoiding predators. But even then, there's a rhythm, a period when activity slows, when you become less responsive to your environment. It might not be sleep as we define it for humans, with brain waves and dreams, but it's the very first evolutionary whisper of rest. It's a pragmatic decision. Conserve energy, avoid danger during vulnerable periods, or simply give your systems a break. This initial rudimentary shutdown provided an adaptive advantage, giving organisms a better chance at survival and reproduction. A quirky tidbit that demonstrates this ancient origin is how even fruit flies, Drosophila melanogaster, those tiny buzzing creatures that seem to exist purely to annoy your fruit bowl, exhibit distinct sleep behaviors. They show reduced movement, a characteristic posture, and a heightened arousal threshold, meaning you need to poke them harder to wake them up. They even experience a sleep rebound if deprived of sleep, meaning they sleep longer later to catch up. So next time a fruit fly lands on your banana, just remember, it might be tired. Historians and biologists still argue whether sleep evolved as a protective measure against predation, a way to conserve energy, or primarily as a time for brain restoration and memory consolidation. Was it about staying safe, saving fuel, or cleaning up the cerebral hard drive? Perhaps it was a combination of all these factors, with different pressures driving its development in different lineages. What's clear is that whatever its initial purpose, sleep proved so vital that it persisted, taking on increasingly complex forms as life itself evolved. It's a universal language spoken by almost every living thing, from the simplest to the most intricate, a testament to its enduring importance. You've just glimpsed sleep's ancient universal roots, stretching back to the earliest forms of complex life. Now, let's dive into the fascinating and perhaps unexpectedly deep sleep habits of one of our earliest vertebrate ancestors, fish. Yes, fish. While you might imagine them endlessly swimming, perpetually alert, this is a mainstream biological fact. Fish do, indeed, sleep, or at least enter a state that is functionally equivalent to sleep, characterized by reduced responsiveness and activity. You can almost see a tiny zebrafish, perhaps, settling down for its own version of a slumber, somewhere deep in the quiet aquatic world. When we talk about fish sleep, we're not talking about them pulling up a tiny blanket and counting imaginary sheep, though that's a fun image. Their sleep looks different because their physiology and environment are different. They don't have eyelids, for example, which is why the old saying, "sleep with one eye open," is particularly apt for them. This lack of eyelids is a quirky tidbit that often surprises people, yet it doesn't prevent them from resting. Instead of closed eyes, you might observe a fish becoming motionless, perhaps settling near the bottom or in a sheltered spot, its fins barely moving, and its breathing slowing down. If you've ever kept fish, you might have noticed them doing this in their tank, looking a bit like they've just given up on life for a moment. Research, particularly on species like the zebrafish, has provided remarkable insights. These small, transparent fish are surprisingly good models for studying sleep. Scientists have observed that zebrafish exhibit two distinct sleep states, astonishingly similar in their characteristics to the slow-wave sleep and REM sleep seen in mammals, including humans. During their slow-wave equivalent, their brain activity shows patterns indicative of deep rest. Then, they enter a state that resembles REM sleep, where there's increased brain activity, though without the characteristic eye movements we associate with human REM, since, no eyelids. This suggests that the fundamental mechanisms and benefits of different sleep stages might be incredibly ancient, predating the evolution of land animals entirely. So, how do fish actually sleep without the comfort of a bed or the ability to close their eyes? Some species, like certain types of wrasse, secrete a mucus cocoon around themselves before settling down for the night, providing both camouflage and protection, a fascinating, if slightly slimy, form of ancient sleep hygiene. Other fish simply find a sheltered spot, perhaps tucked into coral, nestled among rocks, or buried slightly in the sand. And some, like the shark, must keep moving to breathe, so their sleep might involve continuing to swim, but with reduced awareness and responsiveness. Imagine having to literally run a marathon while asleep just to keep yourself alive. Sounds exhausting, even if you are unconscious. Historians and evolutionary biologists still argue whether the presence of these two distinct sleep states in fish indicates a homologous evolutionary origin with mammalian sleep, meaning they share a common ancestor who had these states, or if they are a result of convergent evolution, meaning the states evolved independently in different lineages due to similar environmental pressures. Was it a shared blueprint from a very distant ancestor, or did nature just stumble upon the same good idea multiple times? Regardless of the exact pathway, The fact that such complex sleep patterns are present in creatures as seemingly simple as fish underscores the profound and ancient importance of rest for all forms of life, hinting at benefits that were crucial even before the first fish decided to take a nap. You've just peered into the slumbering world of fish, revealing how deeply rooted sleep is in the tree of life. Now, let's broaden our scope and explore the incredible diversity of rest that unfurls across the vast animal kingdom. This is a mainstream biological fact. While the form sleep takes varies wildly, a sleep-like state, characterized by reduced activity, decreased responsiveness to stimuli, and a generally reversible state of unconsciousness, is observed in nearly all animal species, from the tiniest insects to the largest mammals. You can almost feel the collective yawn spreading across the planet, from the buzzing bee to the slumbering bear. Imagine a tiny fruit fly settling motionless on a leaf for several hours, only to resume its frantic buzzing activities later. Or consider a snail retreating into its shell for days during periods of drought, entering a state of estivation that serves a similar purpose to sleep, conserving energy and protecting itself from harsh conditions. These seemingly simple creatures demonstrate that the fundamental drive for rest isn't exclusive to creatures with complex brains. It's a primal, energy-saving, and restorative imperative that has been honed by millions of years of evolution. One of the most fascinating aspects, and a quirky tidbit, is how certain animals adapt their sleep to their unique environments or predatory pressures. Take the bird. While most land birds perch and sleep with their heads tucked under a wing, some can perform what's called unihemispheric slow-wave sleep, sleeping with one half of their brain while the other half remains awake. This allows them to literally sleep with one eye open to watch for predators, or even to continue flying. Imagine needing to stay partially awake while flying across an ocean. It's a logistical nightmare for a human, but for some birds, it's just Tuesday. This incredible adaptation allows them to manage both the need for rest and the constant threat of danger. Then there are the marine mammals, like dolphins and whales, which also exhibit unihemispheric sleep. They cannot afford to become fully unconscious underwater, as they need to surface regularly to breathe. So, they shut down one half of their brain at a time, allowing the other half to remain active enough to control breathing and maintain vigilance against predators. They literally swim in circles while half asleep, always ensuring they reach the surface for a breath of air. It's a remarkable evolutionary compromise between the absolute need for sleep and the unforgiving demands of their aquatic environment. You probably wouldn't survive trying to sleep like that on your futon. Historians and evolutionary biologists still argue whether the fundamental purpose of sleep, energy conservation versus brain restoration, is universal across all these diverse species, or if different environmental pressures have led to different primary reasons for sleep's existence in various lineages. Is the underlying why of sleep the same for a fruit fly as it is for a whale? Regardless, the sheer ubiquity of sleep, in its multitude of forms, underscores its profound importance. It's a testament to nature's ingenuity, constantly finding new ways to ensure that every living creature gets the essential rest it needs to survive, thrive, and continue the endless dance of life on this planet. You've glimpsed the diverse sleep of the animal kingdom, from the perpetually moving shark to the half-brained dolphin. Now, let's narrow our focus and travel back in time, stripping away the comforts of modern life to envision the sleeping world of our very own ancestors, prehistoric humans. This is a mainstream anthropological fact. For the vast majority of our species' existence, human sleep was dictated almost entirely by natural cycles of light and dark, and the constant imperative of survival. You can almost feel the cool dampness of a cave floor, the subtle shift in air as the sun dips below the horizon, signaling a time for rest. Imagine your ancient self, a hunter-gatherer living millennia ago. Your bedroom might be a sheltered cave, a crude lean-to, or simply a spot beneath the open sky. There are no alarm clocks, no streetlights, no late-night TV binges. Your sleep schedule is synchronized with the environment. You likely went to rest shortly after dusk, when the dangers of the night increased and the ability to forage or hunt diminished. And you probably awoke with the first blush of dawn, eager to make the most of the daylight hours for survival. It was a rhythm dictated by the sun and the moon, a primal dance that modern life has largely forgotten. One of the quirky tidbits about prehistoric human sleep is the archaeological evidence suggesting they often slept on or in communal spaces. While individual families might have had designated spots, the concept of a private, isolated bedroom was virtually non-existent. Early humans likely slept in close proximity to their group, providing warmth, mutual protection from predators, and a sense of security. Imagine drifting off to sleep with the quiet breathing of your entire clan around you, a chorus of snores and murmurs. It's a far cry from your solo bed in a quiet room, isn't it? This communal sleeping arrangement likely fostered a heightened sense of group cohesion and shared vigilance. The quality and continuity of sleep for early humans would have been very different from ours. There were constant threats, nocturnal predators, rival groups, and the simple discomforts of nature. This likely meant sleep was often interrupted, fragmented, and probably much lighter than the deep, uninterrupted slumber many of us crave today. They couldn't afford the luxury of being completely out of touch with their surroundings. A rustle in the bushes, the hoot of an owl. These sounds could mean danger, requiring immediate arousal. You wouldn't survive long if you slept through a saber-toothed tiger's prowl, would you? Historians and anthropologists still argue whether early human sleep patterns primarily resembled a single, long, consolidated block, monophasic sleep, or if they were more fragmented, perhaps involving a period of wakefulness in the middle of the night, biphasic or polyphasic sleep. Some theories suggest a first sleep and a second sleep, separated by an hour or two of quiet activity, as was common in pre-industrial societies before the advent of widespread artificial light. Was our natural rhythm always a single stretch, or was it a more broken pattern? Regardless, the overwhelming environmental pressures and the absence of artificial illumination profoundly shaped how, where, and when our ancestors caught their vital rest. A stark contrast to the climate-controlled, light-polluted sleep environments we inhabit today. You've imagined the nocturnal world of our ancient ancestors, their sleep dictated by the sun and the moon. Now let's explore a particularly fascinating and slightly uncanny sleep adaptation: unihemispheric sleep in the sea. This is a mainstream biological fact. Certain aquatic mammals, most notably dolphins and whales, possess the astonishing ability to sleep with only one half of their brain at a time, while the other half remains awake. You can almost feel the cool, dark currents of the ocean, and visualize a magnificent creature gracefully moving, even in its slumber. Imagine a dolphin effortlessly gliding through the water, seemingly wide awake. Yet, one side of its brain is in a state of deep, slow-wave sleep, while the opposite eye remains open, constantly scanning the environment. The other half of its brain, along with the corresponding eye, is fully alert, processing sensory information and ensuring the animal continues to surface for breaths. After a period, they switch, allowing the previously awake hemisphere to rest. It's an evolutionary marvel, a biological workaround to the critical problem of needing to breathe air while living in water and also remaining vigilant against predators. It's like trying to drive a car and sleep at the same time, but somehow they pull it off. You probably wouldn't survive trying to nap during your morning commute like that. This unique form of sleep is a quirky tidbit that utterly redefines our human-centric understanding of rest. For us, sleep means complete unconsciousness, a vulnerable state where we're essentially offline. But for these marine giants, complete unconsciousness is a death sentence. Their breathing isn't automatic like ours. They have to consciously decide to take a breath. So this half-sleep allows them to continue surfacing for air, avoid drowning, and remain aware of potential threats like sharks or passing ships. It's an incredible balancing act, a testament to the immense evolutionary pressures that shape their survival. The mechanics of this partial sleep involve specific patterns of brain activity. When one hemisphere is experiencing slow-wave sleep, the deep, restorative stage, the electrical activity slows down in that half of the brain, while the other half shows waking patterns. This localized sleep is visually evident, as the eye controlled by the sleeping hemisphere may be closed or partially closed, while the other remains open. This ability allows for continuous vigilance and respiratory control, critical for their survival in a dynamic and often dangerous aquatic environment. Historians and evolutionary biologists still argue whether unihemispheric sleep is an ancient, primitive form of sleep, perhaps hinting at how sleep evolved before complete brain synchronization, or if it's a highly specialized, derived adaptation that evolved relatively recently in response to specific aquatic pressures. Was it an ancient blueprint or a modern innovation? Regardless, observing marine mammals helps us understand the fundamental flexibility of sleep and its profound importance across the animal kingdom. It forces us to reconsider what sleep truly means, pushing the boundaries of our understanding beyond our own familiar, full-brained slumber. You've delved into the specialized sleep of marine mammals and the universal presence of rest. Now, let's take a broader look at the sheer diversity of sleep across different species, emphasizing that while the fundamental need for rest is constant, its expression is incredibly varied. This is a mainstream biological fact. Almost every animal group, from the smallest insect to the largest elephant, exhibits some form of sleep-like behavior, each adapted to their unique ecological niche and survival strategies. You can almost feel the gentle hum of life, each creature finding its own rhythm of rest and activity. Imagine a tiny bee, seemingly tireless as it flits from flower to flower. Yet, at night, bees become motionless in their hives, their antennae drooping, showing clear signs of a sleep-like state. Or consider a snail, which might enter periods of prolonged inactivity, sometimes lasting for days, burying itself in the soil to escape dry conditions. These periods, while not sleep, in the same way a human sleeps, serve similar restorative and energy-conserving purposes. It underscores that sleep isn't just about a complex brain. It's about the basic needs of a living organism. A particularly fascinating quirky tidbit is how some insects, like certain species of cockroaches, show distinct sleep-wake cycles and even sleep rebound if deprived of rest, just like humans. Imagine a tiny cockroach in its nocturnal hideaway, quietly catching up on sleep after a stressful day of scavenging crumbs. It really puts a new spin on those late-night kitchen encounters, doesn't it? This widespread presence of sleep-like states in invertebrates suggests that the underlying biological mechanisms for rest are incredibly ancient, predating the evolution of vertebrates by hundreds of millions of years. As we move up the evolutionary ladder, the complexity of sleep often mirrors the complexity of the animal. Large herbivores, like elephants and giraffes, often have very short sleep durations, sometimes only a few hours a day, much of it standing up. This is a pragmatic adaptation. Being large makes them less vulnerable to predators, but also means it's hard to quickly get up if lying down, and they need immense amounts of time for foraging. They might snatch short bouts of deeper sleep while lying down, but their overall pattern is one of vigilance. In contrast, many predators, like cats and lions, can afford to sleep for much longer periods, often up to 16 hours a day, because they can hunt efficiently and then use long periods of rest to conserve energy. Historians and biologists still argue whether the amount of sleep an animal needs is primarily determined by its metabolic rate, its vulnerability to predators, or the complexity of its brain. Is it about energy, safety, or mental processing? Perhaps it's a dynamic interplay of all these factors, constantly shaping the evolutionary pressures on sleep duration and patterns. What's clear is that the diversity of sleep across species is a testament to nature's boundless ingenuity, adapting a fundamental biological need to every conceivable lifestyle and environment. From the tiniest dozing insect to the half-awake whale, the imperative to rest is a universal constant, ensuring that life, in all its forms, can renew and persist. You've seen the incredible variety of sleep across the animal kingdom, from insects to giants. Now, let's soar into the skies and explore the unique challenges and adaptations of avian snoozing. This is a mainstream biological fact. Birds, like most vertebrates, exhibit sleep, but their ability to manage rest, especially during long migrations or in precarious environments, is truly remarkable. You can almost feel the gentle currents of the wind under their wings, even as they drift into moments of slumber. Imagine a swift, tiny bird making an incredible transatlantic journey. How does it get any rest without plummeting into the ocean? Or a duck floating peacefully on a pond, seemingly oblivious to the world around it? The answer lies in specialized adaptations, some of which we've briefly touched on. Birds, like marine mammals, are masters of unihemispheric slow-wave sleep, USWS. This means they can literally sleep with one half of their brain, while the other half remains awake and alert. A quirky tidbit that demonstrates this perfectly is how birds arrange themselves in a flock. When a flock of ducks or geese rests on water, the birds on the outer edges will often use USWS, keeping one eye open, the one facing outwards, to watch for predators, while the birds in the center of the flock can afford to engage in full bihemispheric sleep. It's like a built-in sentry system where the perimeter guards are always half awake. Imagine trying to coordinate a group nap like that with your friends. Okay, you take the left half, I'll take the right, and let's switch at 3 a.m. Beyond vigilance, birds also face unique challenges regarding sleep during their incredibly demanding long-distance migrations. Scientists have long speculated whether they truly sleep in flight. Recent research using tiny EEG devices attached to birds has provided astonishing evidence. For example, frigate birds, known for their weeks-long flights over the ocean, have been shown to engage in brief, very short bouts of USWS, even while actively soaring. They might snatch a mere few seconds or minutes of sleep at a time, often during a long glide, still controlling their flight path. It's an incredible feat of multitasking, combining rest with essential navigation. During these in-flight snoozes, they often preferentially put one hemisphere into slow-wave sleep, typically the one connected to the eye that faces their direction of travel, allowing the other hemisphere and eye to remain alert. This allows them to stay aware of their surroundings and avoid mid-air collisions, which, would really ruin their day. They also seem to enter brief bursts of REM sleep, but only for a few seconds, preventing them from going into the full muscle atonia state that could lead to a disastrous fall. Historians and biologists still argue whether the primary driver for the evolution of unihemispheric sleep was predator avoidance, energy conservation during prolonged activities, or a combination of both. Was it about staying safe or saving fuel? What's clear is that avian sleep patterns are a stunning example of evolution tailoring a fundamental biological need to extreme environmental and behavioral demands. From the deepest slumber on a branch to the fleeting micronaps high above the ocean, birds remind us that sleep is not a one-size-fits-all phenomenon, but a beautifully intricate dance with the demands of life itself. You've just witnessed the marvel of avian sleep, adapted for flight and vigilance. Now, let's return to the water, but this time to the magnificent world of marine mammal rest, where the imperative to breathe air adds another layer of complexity to their slumber. This is a mainstream biological fact. Marine mammals like dolphins, whales, and seals have evolved fascinating and diverse ways of sleeping that allow them to balance the need for rest with the critical requirements of surfacing for air and avoiding predators. You can almost feel the deep pressure of the ocean, the rhythmic pulses of the currents, and the quiet vigilance of these creatures even in their moments of repose. Imagine a sleek, powerful sperm whale diving thousands of feet into the abyss to hunt. When it's time to rest, these giants perform an astonishing feat. They will sometimes vertically suspend themselves just below the surface, completely motionless, for periods of up to 90 minutes. It's a truly quirky tidbit. Picture a pod of these massive animals bobbing silently, heads pointed upwards, looking like colossal, living submarines in a state of deep, collective meditation. This behavior, likely a form of deep sleep, was only fully observed relatively recently, as it's rare and often occurs in remote ocean areas. It suggests a complete shutdown of both brain hemispheres, a brief period of truly unconscious sleep. However, for many other marine mammals, particularly those that need to be more consistently vigilant or that breathe more frequently, unihemispheric slow-wave sleep, USWS, which we discussed with birds, is the norm. Dolphins and porpoises, for instance, are classic examples. They can literally shut down one side of their brain, along with its corresponding eye, allowing the other side to remain active enough to control their breathing reflex and keep an open eye on their surroundings. They'll often swim slowly in circles during these periods of half sleep. Imagine trying to explain to your pet dog that it needs to run on a treadmill for an hour while half asleep just to avoid suffocation. This half asleep state allows them to manage several critical survival functions. Firstly, respiration, as they must consciously initiate each breath. A fully unconscious marine mammal would simply drown. Secondly, thermoregulation, as remaining partially active helps them maintain body temperature in cold waters. And thirdly, predator avoidance, as keeping one eye open and one brain hemisphere active provides continuous awareness of threats. It's a remarkable compromise between the absolute biological need for restorative sleep and the unforgiving demands of their aquatic environment. Historians and evolutionary biologists still argue whether the presence of USWS in both birds and marine mammals is an example of convergent evolution, where similar traits evolve independently in different lineages due to similar environmental pressures, or if it points to a much more ancient, shared ancestor that had this capacity, which was then lost in terrestrial mammals but retained in others. Was it a lucky coincidence or a very old trick? Regardless, the intricate sleep patterns of marine mammals highlight the extraordinary ways in which life adapts to fundamental needs, showing us that sleep is far from a simple act, but a complex and vital negotiation with the environment. You've delved into the remarkable adaptations of marine mammals, demonstrating sleep's evolutionary flexibility. Now, let's turn our attention to the sleeping habits of our own direct ancestors, stretching back into the deep past, prehistoric human sleep. This is a mainstream anthropological fact. For the vast majority of human existence, before the glow of artificial light and the comfort of manufactured shelters, our sleep patterns were profoundly shaped by the raw realities of the natural world, the rising and setting of the sun, the presence of predators, and the needs of the group. You can almost feel the chill of an ancient night, the rustle of leaves, and the quiet vigilance of an ancestral group huddling together. Imagine a group of early Homo sapiens settling down for the night, perhaps in a shallow cave, under a rock overhang, or simply in a sheltered clearing within a forest. There were no beds as you know them, no soft mattresses or plush pillows. Their beds were often simple depressions in the earth, sometimes lined with leaves, grass, or animal hides for a modicum of warmth and comfort. These rudimentary sleeping arrangements were driven by practicality, providing insulation from the cold ground, a basic barrier against crawling insects, and perhaps a small measure of concealment. It's a far cry from your memory foam mattress and climate-controlled bedroom, isn't it? You wouldn't survive a single night trying to sleep on that, would you? A quirky tidbit that fascinates anthropologists is the concept of shared communal sleeping. Unlike modern Western societies where individual bedrooms are the norm, prehistoric humans almost certainly slept in close proximity to one another. This wasn't just about warmth, it was a crucial survival strategy. A larger group meant more eyes and ears to detect predators, and the sheer presence of many bodies could deter some threats. Imagine the subtle sounds of a group breathing, the occasional murmur, the comforting presence of others nearby. This collective slumber fostered a sense of security and group cohesion, making everyone a silent guardian for the rest. The duration and continuity of prehistoric sleep would have also been very different from contemporary patterns. Without artificial light, activity largely ceased at dusk. This likely meant going to sleep relatively early and waking with the sunrise, maximizing the daylight hours for essential activities like foraging, hunting, and tool-making. However, their sleep was also likely to be more fragmented. The constant threat of nocturnal predators, the need for individuals to keep watch, or even just the discomfort of the environment would have led to frequent awakenings. It wasn't the deep, uninterrupted 7 to 9 hours we strive for. It was likely broken, lighter sleep, punctuated by periods of alertness. Historians and anthropologists still argue whether the natural, pre-industrial human sleep pattern was primarily monophasic, one long block of sleep, like most modern people attempt, or biphasic, two shorter sleep periods separated by a period of wakefulness during the night. Evidence from historical documents suggests that first sleep and second sleep were common in pre-industrial Europe, leading some to theorize this might be our natural rhythm. Was it always a single stretch of sleep, or was it naturally broken into segments? Regardless, the overwhelming environmental pressures of survival and the absence of light pollution shaped a sleep landscape vastly different from our own, emphasizing vigilance and adaptability over deep, undisturbed slumber. You've just imagined the raw, exposed sleep of our earliest human ancestors. Now, let's consider a slightly more refined, yet still primal, form of rest as we peer into the lives of early Homo sapiens and their close relatives, the Neanderthals and Denisovans. While direct evidence of their sleep is, predictably, scarce, archaeological findings offer fascinating clues about their sleeping environments, suggesting a gradual move towards more deliberate and comfortable resting places. This is a mainstream anthropological fact. Early hominins sought shelter for rest, and their choices reveal insights into their daily lives and environmental challenges. You can almost feel the earthy scent of a carefully chosen alcove, or the subtle warmth of shared body heat within a sheltered space. Imagine a group of Neanderthals in a large cave, perhaps during the depths of an ice age. They weren't just flopping down anywhere. Evidence from archaeological sites suggests that they, and early Homo sapiens, made conscious choices about where they rested within a cave, often preferring elevated areas for better drainage and visibility, or deeper recesses for warmth and protection. They might have used rudimentary bedding, layers of animal hides, or perhaps even flattened beds of organic materials like grasses or ferns. A quirky tidbit is the discovery of what some archaeologists interpret as sleeping hollows or beds in certain Neanderthal cave sites. Slight depressions in the ground suggesting repeated use and perhaps even attempts to soften the sleeping surface. It's like finding the faint outlines of ancient lumpy mattresses. The Neanderthals, living in often harsh, cold environments, would have prioritized warmth and safety for their slumber. Huddling together, perhaps with a central fire, would have been crucial not only for warmth but also for deterring predators. The very act of gathering in a protected space for extended periods of rest would have reinforced social bonds and group cohesion. You can almost hear the soft breathing of the group, a shared sense of vulnerability and mutual reliance as the long, cold night stretched before them. While we don't have direct fossilized brains to analyze their sleep stages, it's highly probable that their sleep patterns shared many similarities with modern humans, including REM and non-REM cycles, given the fundamental importance of these stages for brain function. However, their sleep would undoubtedly have been fragmented by the need for vigilance against predators, the discomfort of their surroundings, and the fluctuating temperatures. Their bedtimes were strictly dictated by the sun, rising with the first light to hunt and gather, and retreating to shelter as darkness fell. Historians and anthropologists still argue whether the complexity of early hominin shelters primarily reflects an advanced cognitive ability for planning and comfort, or if it was simply a direct, pragmatic response to environmental pressures and predator threats. Was it about feeling cozy or simply surviving the night? Regardless, the archaeological traces of their resting places offer valuable clues about the daily lives and inherent vulnerabilities of our ancient relatives. These simple, earthy nests remind us that even without the trappings of modern bedrooms, the universal need for a safe and restorative place to rest has been a constant thread throughout human history, connecting us directly to the quiet slumbers of our long-lost ancestral family. You've just considered the rudimentary sleeping arrangements of our ancient ancestors, nestled in caves and hollows. Now, let's delve into a fascinating theory about their actual sleep patterns, moving beyond simply where they rested to how they rested. This brings us to the intriguing concept of biphasic sleep, also known as segmented or polyphasic sleep. This is a mainstream anthropological hypothesis, supported by historical evidence, suggesting that pre-industrial humans did not necessarily sleep in one continuous block, like many of us attempt today, but rather in two distinct segments throughout the night. You can almost feel the quiet stillness of the middle of the night, a period of calm wakefulness before the second descent into slumber. Imagine a night without electric lights, without the perpetual glow of screens. As dusk fell, your ancient self would retreat, likely entering a first sleep that lasted for a few hours. Then, in the deepest part of the night, perhaps around midnight or a bit later, you might naturally awaken. This wouldn't be an alarming awakening. Rather, it would be a quiet, liminal period, lasting an hour or two. During this time, you might stir the fire, check on children, engage in quiet conversation with family members, perhaps reflect on dreams, or even perform light chores. There was no pressure to immediately fall back asleep. After this period, you would then ease into a second sleep that would last until dawn. It sounds like a rather civilized, if primitive, way to spend the wee hours. A quirky tidbit that strongly supports this theory comes from historical records. Before the advent of artificial illumination, especially gas and electric lighting, references to first sleep and second sleep were common in literature, legal depositions, and medical texts from various cultures, particularly in Europe. People talked about waking between sleeps as a normal, unremarkable part of their nightly rhythm. It wasn't until the Industrial Revolution pushed people into rigid work schedules and artificial light extended the waking day that the idea of one long, uninterrupted night's sleep became the cultural ideal. Imagine telling someone from the 17th century that you try to sleep for 8 hours straight. They might think you were ill or incredibly lazy. This biphasic pattern might have offered several adaptive advantages to our ancestors. The midnight wakefulness could have served as a natural period for vigilance, allowing individuals to check for predators or other threats without disrupting a single, vital sleep block. It also provided a calm, quiet time for reflection, social bonding, or even intimate activities, free from the demands of daylight, foraging, or hunting. Some evolutionary biologists theorize that this fragmented sleep could be our true natural rhythm, and that our modern attempts to force a single long sleep block might be at odds with our inherent biology, potentially contributing to modern sleep issues. Historians and sleep scientists still argue whether biphasic sleep was a universal human pattern before artificial light, or if it was more prevalent in certain cultures or climates. Was it a fundamental human sleep pattern, or a culturally flexible response to environmental cues? Regardless, the concept of biphasic sleep offers a fascinating glimpse into a rhythm of life that was deeply intertwined with the natural world, suggesting that perhaps our ancestors understood the nuances of rest in ways that modern society has largely forgotten. As you drift closer to your own slumber, consider the possibility that waking in the middle of the night might not be a sign of poor sleep, but a faint echo of our very ancient past. You've just considered the possibility of a segmented sleep pattern in ancient humans. Now let's turn our attention to one of our closest extinct relatives, the Neanderthals, and ponder what their nights might have been like. While we can't interview a Neanderthal about their sleep preferences, unfortunately the technology isn't quite there yet, a mainstream scientific fact is that recent genetic studies offer fascinating, albeit indirect, clues about their potential sleep-wake cycles, suggesting a subtle influence on some modern human sleep patterns. You can almost feel the chill wind sweeping through a Neanderthal cave, and imagine a huddle of robust figures settling down for the night. Imagine a Neanderthal living through a harsh Ice Age winter in Europe. Their survival depended on intense physical activity, hunting large game, processing hides, maintaining fires, and navigating treacherous landscapes. This demanding lifestyle would have necessitated effective rest. Like early Homo sapiens, their sleep would have been dictated by the natural light-dark cycle, as well as the constant threat of predators and the biting cold. They likely slept in communal groups within caves or rock shelters, maximizing warmth and collective vigilance against dangers. Their robust physiques and powerful musculature probably meant they could sleep soundly even on relatively hard surfaces, though they undoubtedly utilized animal hides and other available materials for insulation and comfort. A quirky tidbit arises from genetic research. Scientists have found fragments of Neanderthal DNA in the genomes of modern humans, particularly those of European and Asian descent. Interestingly, some of these inherited Neanderthal genes are linked to circadian rhythms, the internal biological clock that regulates our sleep-wake cycles. Specifically, certain Neanderthal gene variants have been associated with a predisposition to be a morning person or to have an earlier sleep onset. It's almost as if your ancestors from tens of thousands of years ago are still subtly nudging you towards an early bedtime, even if you're currently trying to scroll through social media at 2 a.m. This suggests that while their sleep environment was vastly different, the fundamental genetic machinery for regulating sleep was shared and, in part, inherited. However, interpreting these genetic clues is complex. While a Neanderthal gene might influence a modern human's sleep tendency, it doesn't tell us definitively how Neanderthals themselves slept. Did these specific gene variants lead to earlier bedtimes for them too? Perhaps as an adaptation to maximize daylight for hunting in high-latitude environments with long winters? Or did other environmental and behavioral factors override these genetic predispositions? The exact interplay remains a fascinating puzzle. Historians and geneticists still argue whether the presence of Neanderthal-derived sleep-related genes in modern humans indicates a direct adaptive benefit from interbreeding, or if they are simply neutral remnants of ancient genetic exchange. Was it a strategic genetic advantage, or just a random inheritance? Regardless, the idea that these long-extinct relatives might still be whispering to our internal clocks, subtly influencing when we feel sleepy or alert, is a profound reminder of our deep connection to the past. The echoes of their ancient slumbers might, in a very real way, still be shaping your own nightly rhythm. You've considered the subtle genetic echoes of Neanderthal sleep in modern humans. Now, let's briefly acknowledge another enigmatic relative from our past, the Denisovans. This is a mainstream anthropological fact. While the Denisovans are a recently discovered group of archaic humans, distinct from both Neanderthals and modern humans, much less is known about their specific daily lives, including their sleep patterns, due to the scarcity of fossil evidence. You can almost feel the deep quiet of their ancient Siberian cave, holding secrets that are only just beginning to be unveiled. Imagine these mysterious Denisovans existing in parallel with Neanderthals and early Homo sapiens across vast stretches of Asia. Like their contemporary hominins, their sleep would have been inextricably linked to the natural environment. They faced the same primal needs for safety from predators, warmth from the cold, and rest to recover from the physical demands of a hunter-gatherer existence. They too would have likely sought shelter in caves or other natural formations, perhaps sharing space communally for security and warmth, much like the Neanderthals. Their sleeping surfaces would have been as rudimentary as any other early human group, relying on natural materials for cushioning and insulation. A quirky tidbit about the Denisovans is that their existence was first identified not by a full skeletal fossil, but by a finger bone and a few teeth found in a cave in Siberia. More recently, a jawbone has been found in Tibet. This extreme scarcity of remains means that most of what we infer about them comes from genetic analysis rather than direct observation of their archaeological sites. Because we have so little direct physical evidence of their daily lives or specific behaviors, details about their sleep are largely speculative. It's like trying to understand someone's entire life story from just a few lost buttons. However, given their close evolutionary relationship to both Neanderthals and Homo sapiens, it's reasonable to infer that the fundamental biological need for sleep would have been present in Denisovans, and that they likely experienced distinct sleep stages, including REM and non-REM sleep, essential for brain health and physiological restoration. The core mechanisms of sleep are incredibly ancient, predating the divergence of these hominin groups. The differences, if any, would likely have been in the duration, fragmentation, and specific environmental adaptations of their sleep, driven by their particular habitats and predatory pressures. Historians and geneticists still argue about the full extent of the Denisovan range and their precise interactions with other hominin groups. What's clear is that the very limited information we have on Denisovan sleep underscores the immense challenges in reconstructing the daily lives of prehistoric humans, particularly for groups known primarily through their genetic signatures. While they remain largely a mystery in terms of their nocturnal habits, their existence reminds us that the story of human sleep is not just our own, but a shared, ancient legacy with long-extinct relatives whose silent slumbers are still whispering hints about the deep history of rest on our planet. You've just considered the enigmatic sleep patterns of the Denisovans. Now, let's fast forward dramatically, sailing through millennia of human evolution, past the dawn of agriculture and the rise of great empires, to a pivotal moment that fundamentally reshaped human sleep, the Industrial Revolution. This is a mainstream historical fact. The widespread adoption of artificial light and the shift from agrarian rhythms to factory schedules profoundly altered when, how, and how much humans slept. You can almost feel the harsh glare of a newly installed gas lamp battling against the natural darkness and the relentless whir of machinery replacing the quiet chirping of crickets. Imagine yourself in a bustling 18th or 19th century factory town. Before this era, human sleep patterns, as we discussed, were largely dictated by the sun. Work started at dawn and ended at dusk. Nights were dark, quiet, and primarily for rest. But with the invention of gas lighting, and later electric lighting, the night could suddenly be extended. Factories could operate 24 hours a day, demanding shifts that stretched far beyond natural daylight. This economic imperative meant that humans were, for the first time, consistently encouraged to override their natural circadian rhythms. It was like suddenly being told you could get an extra 8 hours of work done every day, but at the cost of your natural sleep schedule. A quirky tidbit is how the very concept of nightlife, or late-night entertainment, really took off with widespread artificial lighting. Before gas lamps, cities essentially shut down after dark. Imagine trying to have a thriving theater scene or late-night cafes with only candles. It was difficult and expensive. But with brighter, cheaper illumination, public spaces, shops, and entertainment venues could stay open longer, offering temptations that further eroded early bedtimes. It's almost as if light bulbs didn't just illuminate rooms. They illuminated an entirely new social rhythm, one that chipped away at the sanctity of the natural night. The impact on the average person's sleep was significant. Factory workers, often living in cramped, noisy conditions, were forced to adapt to shift work, disrupting their internal clocks. Farmers, who had always worked by the sun, now saw their children or neighbors toiling under artificial lights for longer hours. The notion of a continuous 8-hour block of sleep began to solidify as the cultural norm, partly because industrial schedules demanded it, and partly because pervasive artificial light eliminated the naturally occurring periods of darkness that might have fostered segmented sleep. Historians and sleep scientists still argue whether the Industrial Revolution merely shifted existing sleep patterns, or if it fundamentally reprogrammed human sleep biology on a societal level, creating a chronic sleep deficit that persists to this day. Was it a cultural adaptation or a biological disruption? Regardless, the long-term impact was clear. Humanity gained extended working and leisure hours, but perhaps at the cost of a deeper connection to its ancient natural sleep rhythms. As you drift off, consider the glow of your own devices and how that faint light connects you to a revolutionary past that fundamentally altered the way we experience the essential act of slumber. You felt the profound shift brought by the Industrial Revolution's artificial light and relentless schedules. Now, let's accelerate even further into our immediate past and present, to the era of constant connectivity and glowing screens. The electronic age and its impact on sleep. This is a mainstream contemporary fact. The proliferation of electronic devices, smartphones, tablets, computers, and televisions, has introduced unprecedented challenges to human sleep patterns. fundamentally altering our exposure to light and information. You can almost feel the cool blue light of a screen on your face, disrupting the natural signals that tell your body it's time to rest. Imagine your bedroom, a sanctuary of rest. Now imagine it filled with the soft glow of a laptop, the constant notifications from your phone, or the mesmerizing flicker of a late-night TV show. Unlike the gas lamps of the Industrial Revolution, which primarily extended work hours, modern electronics have infiltrated our leisure time, extending the waking day far past sunset and right into our beds. We're bombarded with light, information, and social stimulation precisely when our bodies are naturally preparing for sleep. It's like trying to coax a baby to sleep by blasting rock music at full volume, completely counterproductive. A quirky tidbit is the concept of revenge bedtime procrastination. This phenomenon, particularly prevalent in cultures with demanding work schedules, describes people deliberately staying up late, sacrificing sleep, simply to reclaim a sense of freedom and personal time that they feel deprived of during their busy days. It's like a quiet rebellion against the demands of modern life, but one that ultimately harms their own sleep. Imagine telling your ancient ancestor that you're staying up late just to look at tiny pictures on a glowing rectangle. They'd probably just shake their head and suggest you gather more firewood. The primary culprit in the electronic assault on sleep is blue light. Screens emit a significant amount of blue light, which is particularly effective at suppressing the production of melatonin, the hormone that signals to your brain that it's nighttime and time to get sleepy. Our bodies interpret this blue light exposure, especially in the evening, as a signal that it's still daytime, effectively pushing back our internal clock and making it harder to fall asleep. This isn't just a subjective feeling. It's a measurable physiological response, directly impacting your circadian rhythm. Historians and sleep scientists still argue whether the long-term effects of widespread electronic device use, particularly on developing brains, will lead to permanent changes in human sleep architecture or an increase in chronic sleep disorders. Are we simply adapting to new stimuli, or are we fundamentally undermining our biological need for restorative rest? What's clear is that the electronic age has created a profound disconnect between our ancient, light-driven sleep biology and our modern, screen-saturated lifestyles. As you ease into your own sleep tonight, consider the deliberate choice to put away your devices, allowing your body to naturally embrace the darkness and reconnect with the millennia-old rhythms of rest. You've just considered how the glow of screens impacts our ability to fall asleep. Now, let's look at another striking consequence of the modern era: the reduced sleep duration many of us experience. This is a mainstream contemporary fact. Over the past century, and particularly in recent decades, the average amount of sleep adults get has significantly decreased, leading to a widespread phenomenon often termed sleep debt or chronic sleep deprivation. You can almost feel the collective weariness, the constant low-grade fatigue that permeates modern society, a quiet hum of insufficient rest. Imagine your great-grandparents living in a time before 24/7 news cycles, before streaming services, and before the pressure to be constantly on. While life certainly had its demands, their days generally concluded with the setting sun, and their homes were often truly dark. Now, compare that to your own daily grind. Early mornings for work or school, late nights for social engagements, deadlines, family responsibilities. and the endless scroll of digital content. Every additional hour of activity chipped away at the precious hours of darkness, the time historically reserved for sleep. It's like trying to fill a bucket with a hole in the bottom. No matter how much you try, you're always losing something. A quirky tidbit that illustrates this trend is how, in some cultures, there's a perceived badge of honor associated with getting by on very little sleep. The "I'll sleep when I'm dead" mentality, or the idea that less sleep equals more productivity, has become ingrained in certain work environments. Imagine bragging to your prehistoric ancestors that you only got 4 hours of sleep last night because you were working late. They'd probably look at you with genuine concern, assuming you were either ill or simply unsuited for survival. This cultural valorization of sleep deprivation is a peculiar modern phenomenon, directly at odds with our biological needs. The numbers are telling. Studies consistently show that the average adult in industrialized nations now gets significantly less than the recommended 7-9 hours of sleep per night, often hovering around 6.5 hours or even less. This isn't just about feeling tired. It's about accumulating a continuous sleep deficit. Your body doesn't get used to less sleep. Instead, it compensates in subtle, often detrimental ways, leading to impaired cognitive function, mood swings, and a weakened immune system. It's a silent, slow-burning fire that impacts almost every aspect of your well-being. Historians and sleep scientists still argue whether this widespread reduction in sleep duration is a reversible consequence of modern lifestyles, or if it represents a more permanent, evolutionary adaptation to an increasingly demanding environment. Are we simply choosing to sleep less, or are we being forced into it by societal pressures? Regardless, the impact is clear. The collective sleep debt of humanity is a significant public health concern, a silent epidemic that undermines productivity, safety, and quality of life. As you prepare for your own rest, consider the precious gift of sleep and the quiet revolution it demands to reclaim those lost hours from the relentless pace of the modern world. You've just considered the growing deficit in our sleep duration. Now, let's delve into why sleep is so incredibly vital, exploring its crucial roles in maintaining both our physical and mental health. This is a mainstream biological fact. Sleep is not merely a period of inactivity. It's an active, complex state during which our bodies and brains perform essential restorative and maintenance functions that are impossible during wakefulness. You can almost feel your body silently working, repairing, and rebuilding itself, while your mind processes the day's experiences, all under the calming cloak of slumber. Imagine your brain like a bustling city that never truly shuts down. During the day, it's a whirlwind of activity, processing sensory input, making decisions, and managing complex thoughts. But even a city needs its downtime for maintenance and waste removal. Sleep provides that crucial window. While you're asleep, your brain isn't just off, it's incredibly busy. It clears out metabolic waste products that accumulate during wakefulness, much like a tiny, efficient cleaning crew tidying up the streets. Without this nightly cleanup, these waste products can build up, potentially impairing brain function over time. It's like trying to run a smart city with overflowing trash cans and broken streetlights. Eventually, things just grind to a halt. A quirky tidbit is the role of glymphatic system, a recently discovered network in the brain that acts like a waste disposal system, and it becomes significantly more active during sleep. Specifically, the brain cells actually shrink in size during sleep, opening up pathways that allow cerebrospinal fluid to flush out toxins, including amyloid beta, a protein implicated in Alzheimer's disease. So, while you're dreaming of flying, your brain is busy taking out the microscopic trash. This is a profound testament to sleep's active, restorative power. Beyond brain maintenance, sleep is a powerhouse for physical restoration. During deep sleep, your body releases growth hormone, essential for tissue repair and muscle growth. Your immune system also gets a significant boost, producing protective proteins called cytokines, which help fight infection and inflammation. Think of it like your body's nightly tune-up and security update. Muscles are repaired, cells are regenerated, and your defenses are strengthened. Chronic sleep deprivation, therefore, leaves you vulnerable, not just to feeling tired, but to a host of physical ailments, from impaired wound healing to increased susceptibility to illness. Historians and sleep scientists still argue whether the primary evolutionary pressure for sleep was brain restoration, the brain maintenance theory, or if it was primarily about energy conservation and avoiding predators during vulnerable periods. Was sleep developed mainly for brain health or for physical survival? Regardless of the initial driver, what's unequivocally clear is that sleep is a multifaceted biological imperative with profound and undeniable consequences for every aspect of our well-being. It's not a luxury, it's a non-negotiable biological necessity, a nightly reset button that allows your complex human system to function optimally. As you prepare to drift off, remember the incredible work your body and mind are doing, silently, powerfully, as you surrender to the vital embrace of rest. You've felt the profound physical and mental repair work that happens during sleep. Now, let's hone in on one of sleep's most astonishing and crucial functions, particularly for your amazing brain: memory consolidation. This is a mainstream neurological fact. Sleep is not just a period of passive rest, but an active state during which the brain processes, organizes, and stores the day's experiences, transforming fragile new memories into stable, long-term knowledge. You can almost feel the silent, intricate work of your neurons, busily filing away information, making sense of the day's deluge. Imagine your brain like a bustling library. Throughout the day, you're constantly acquiring new books, facts, experiences, skills, emotions. These new books are initially scattered, temporary, and easily lost. When you go to sleep, especially during certain stages, it's as if the librarians come out to meticulously sort, categorize, and shelve all those new books in their proper places. They decide what to keep, what to discard, and how to connect the new information with what you already know. Without this nightly process, your mental library would become a chaotic mess, making it difficult to recall information or learn new things effectively. It's like trying to find a specific book in a library where everything is just piled haphazardly on the floor. Good luck with that. This memory processing primarily occurs during two key sleep stages: slow wave sleep, SWS, often called deep sleep, and rapid eye movement, REM sleep, the stage associated with vivid dreaming. During SWS, the brain appears to replay newly learned information, transferring it from a temporary storage area, like the hippocampus, to more permanent storage in the cortex. It's like the brain is doing a mental rehearsal, reinforcing the neural connections that form new memories. A quirky tidbit is how studies have shown that if you learn a new motor skill, like playing a new piece of music on an instrument or practicing a difficult dance move, you actually get better at it after a night's sleep, even without further practice, thanks to this overnight consolidation. Your brain literally practices in its sleep. Then comes REM sleep, which seems crucial for integrating new information with existing knowledge and for processing emotional memories. While SWS might be about consolidating the what of memories, REM sleep often helps with the how and why, connecting the dots and finding meaning. It's during this stage that the brain might work through complex problems or creative challenges, often leading to aha moments upon waking. This is why a good night's sleep is often recommended before a big exam or a creative project. Your brain needs time to chew on the information. Historians and neuroscientists still argue about the precise mechanisms and specific roles of SWS versus REM sleep in different types of memory consolidation. Is SWS primarily for declarative memories, facts and events, and REM for procedural, skills, and emotional memories, or is their interplay more complex? Regardless of the exact division of labor, the undeniable fact is that sleep is a non-negotiable requirement for optimal learning and memory. When you sacrifice sleep, you're not just tired, you're actively undermining your brain's ability to absorb, retain, and make sense of the world around you. So, as you prepare to rest, give a silent thank you to your brain's tireless night shift, diligently working to cement the knowledge you've gained. You've just seen how sleep diligently works to consolidate your memories. But your brain isn't the only organ getting a major tune-up during your nightly repose. Let's explore the critical process of physical restoration in slumber, where your body actively repairs, rejuvenates, and fortifies itself. This is a mainstream biological fact. Sleep is a vital period for cellular repair, hormone regulation, and overall physiological maintenance, essential for optimal physical functioning. You can almost feel the quiet hum of cellular regeneration, the subtle shifts as your body performs its vital nightly overhaul. Imagine your body like a complex machine that's been running all day. During waking hours, you're constantly expending energy, building up stress, and incurring microscopic wear and tear on your tissues. Sleep provides the crucial downtime for this machine to undergo necessary repairs and maintenance. It's when your muscles recover from the day's activity, tears in tissue are mended, and cellular damage is addressed. This active repair work is why you often feel refreshed and ready to go after a good night's sleep, even if your day was physically demanding. It's like your own personal in-house repair shop, diligently working while you're off duty. A quirky tidbit that highlights this restorative process is the release of growth hormone, GH. While often associated with childhood growth, GH is also vital for adults. A significant portion of daily GH secretion occurs during deep, slow-wave sleep. This hormone plays a key role in cell reproduction and regeneration, repairing muscle tissue, strengthening bones, and converting fat into energy. So, even if you're not growing taller, your body is still using sleep to rebuild and repair itself, making sure you're ready for the next day's challenges. It's almost as if your body has a tiny nocturnal construction crew, busy at work patching things up. Beyond direct repair, sleep also plays a pivotal role in hormone regulation. Proper sleep helps regulate hormones related to appetite, like ghrelin and leptin, which control hunger and satiety, stress, cortisol, and even insulin sensitivity. Chronic sleep deprivation can throw these delicate balances out of whack, leading to increased hunger, weight gain, higher stress levels, and an elevated risk of conditions like type 2 diabetes. It's like a conductor trying to lead an orchestra, but half the musicians are off-key because they're exhausted. Historians and sleep scientists still argue about the precise evolutionary origins of these restorative processes during sleep. Did sleep initially evolve for physical restoration, or did the restorative benefits become secondary adaptations that became increasingly important as organisms grew more complex? Was it a primary driver or a beneficial side effect? Regardless, the undeniable truth is that without adequate sleep, your physical body simply cannot perform its essential maintenance tasks. It's a non-negotiable biological requirement, the ultimate form of self-care. As you prepare to drift off, allow your body to surrender to this profound process, trusting in its ancient wisdom to repair, rejuvenate, and prepare you for the day ahead. You've just explored how sleep orchestrates the physical repair of your body. Now, let's consider another vital role of slumber, one that acts as your body's silent sentinel: its profound impact on your immune system. This is a mainstream biological fact. Adequate sleep is absolutely crucial for a robust and effective immune response, helping your body defend against infections, inflammation, and chronic diseases. You can almost feel your body's defenses strengthening, silently preparing to ward off invisible invaders, all while you're peacefully dreaming. Imagine your immune system as a highly trained army, constantly patrolling your body, identifying threats like viruses, bacteria, and damaged cells. During wakefulness, this army is busy on active duty, but it also needs downtime to regroup, produce new soldiers, and replenish its ammunition. Sleep provides this essential strategic pause. When you're asleep, your immune system releases protective proteins called cytokines. These tiny proteins are critical for fighting infection and inflammation, and they also help regulate your overall immune response. It's like your body's nightly intelligence briefing and weapons manufacturing session, making sure your defenses are fully stocked and ready for any challenge. Chronic sleep deprivation, even just consistently getting an hour or two less than you need, can significantly suppress your immune function. Studies show that people who don't get enough sleep are more likely to get sick after being exposed to a virus, and they take longer to recover. Their bodies produce fewer infection-fighting antibodies, and the activity of natural killer cells, a type of white blood cell that attacks virus, infected cells, and cancer cells, is reduced. It's like sending your army into battle with half their supplies and no backup. Not a great strategy for victory. Historians and immunologists still argue about the precise evolutionary pressures that led sleep to become so deeply intertwined with immune function. Was sleep's role in immunity a primary driver of its evolution, or a beneficial side effect that became highly advantageous over time? Regardless of the exact pathway, the undeniable link between quality sleep and a strong immune system is a cornerstone of modern health. Prioritizing your sleep isn't just about feeling good. It's a fundamental act of self-preservation, providing your body's defenses with the crucial downtime they need to keep you healthy and resilient against the constant threats of the world. You've just seen how sleep diligently strengthens your immune system. Now, let's explore one of the most intriguing and mysterious aspects of our nocturnal lives: the science of dreams. This is a mainstream psychological and neurological fact. Dreaming, particularly during rapid eye movement. REM, sleep, is a universal human experience, and scientists are constantly working to understand its complex functions, from emotional regulation to creative problem solving. You can almost feel the bizarre, illogical pull of a dream, transporting you to a world where anything is possible, even as your body remains still. Imagine the sheer strangeness of dreams. One moment you're flying, the next you're taking an exam you haven't studied for, and then suddenly you're having a conversation with a talking badger. Dreams are often vivid, emotionally charged, and notoriously difficult to recall upon waking, yet they feel incredibly real in the moment. For centuries, dreams were seen as messages from the gods, prophecies, or windows into the subconscious. While modern science has shifted away from purely mystical interpretations, the profound impact of dreams on our psyche is undeniable. A quirky tidbit about dreams is the phenomenon of lucid dreaming, where the dreamer becomes aware that they are dreaming and can, to some extent, control the dream narrative. Imagine realizing mid-dream that you can fly or conjure objects at will. It's like becoming the director of your own nocturnal movie. While not everyone experiences lucid dreams frequently, it highlights the brain's incredible capacity for consciousness, even during sleep, and the often thin veil between our waking and dreaming realities. The primary stage for dreaming is REM sleep. During REM, your brain activity actually resembles that of wakefulness. Your eyes dart back and forth, hence rapid eye movement, and your muscles become temporarily paralyzed, a state called atonia, to prevent you from acting out your dreams. Scientists still debate the exact function of dreams, but several theories prevail. Some suggest dreams are a way for the brain to process emotions, allowing us to safely confront fears or anxieties. Others propose they play a role in memory consolidation, helping to integrate new information and strengthen neural connections. Yet another theory posits that dreams are simply a byproduct of the brain's nightly housekeeping, a random firing of neurons that your conscious mind attempts to weave into a coherent narrative. Historians and neuroscientists still argue about whether dreams serve a singular primary purpose, or if they are a multifunctional phenomenon with different roles in emotional processing, memory, and creativity. Are they merely neural static or profound insights? Regardless, the universality of dreaming across human cultures, and even in many animal species, yes, some animals show REM-like states, suggesting they might dream too, though perhaps not of talking badgers, underscores its deep evolutionary significance. As you prepare to drift off, consider the incredible journey your mind is about to embark on, a nightly descent into the wondrous and often bewildering landscape of dreams, where the boundaries of reality blur and the mysteries of the subconscious come alive. You've just explored the enigmatic world of dreams. Now, let's consider a less pleasant but equally illuminating aspect of sleep's long history: sleep disorders through history. You've just considered the historical presence of sleep disorders. Now, let's explore a broader sociological aspect of our nightly routines: cultural variations in sleep habits. This is a mainstream anthropological and sociological fact. While the biological need for sleep is universal, the way societies approach and organize sleep, when people sleep, where they sleep, and even how much emphasis they place on it, vary significantly across different cultures and historical periods. You can almost feel the diverse rhythms of communities across the globe, each with its own unique approach to rest. Imagine stepping into a traditional Amazonian village where people sleep in hammocks arranged communally, stirring frequently throughout the night in short bursts, perhaps to check on children or maintain a fire. This polyphasic or segmented sleep pattern is common in many non-industrialized societies, contrasting sharply with the consolidated, monophasic sleep ideal prevalent in many Western cultures. Or consider the practice of co-sleeping, where infants and young children share a bed or room with parents, a common practice in many parts of the world but often viewed differently in others. It's like comparing a synchronized swimming team to a casual group swim. Different styles, same water. A quirky tidbit is the historical phenomenon of the siesta in Mediterranean and Latin American cultures. This afternoon nap, often taken after the midday meal, is not merely a sign of laziness but a cultural adaptation to hot climates and long working days. Businesses might close for a few hours, allowing people to rest during the hottest part of the day before resuming activities in the cooler evening. While modern work pressures have eroded the siesta in many places, its persistence highlights how cultural norms can prioritize periods of rest to optimize daily productivity and comfort. Imagine trying to explain to your boss that you're taking a 2-hour nap after lunch because it's cultural. These cultural variations extend to attitudes towards sleep itself. In some societies, sleep is viewed as a necessary evil, a period of unproductive time that should be minimized. In others, it's a sacred time for spiritual reflection or a communal activity. The emphasis placed on getting enough sleep or the precise duration of sleep also varies widely. These differences are often shaped by climate, subsistence patterns, e.g., farming versus factory work, social structures, and prevailing beliefs about the body and mind. Historians and cultural anthropologists still argue whether these diverse sleep habits are primarily deep-seated cultural traditions or pragmatic adaptations to environmental and economic conditions. Are they cultural preferences or practical necessities? Regardless, observing these variations challenges the notion of a single correct way to sleep, reminding us that our modern sleep patterns, often dictated by artificial light and demanding schedules, are just one cultural expression of a universal biological need. As you prepare to rest, consider the diverse ways humanity has sought slumber, a testament to the endless adaptability of both our bodies and our cultures in the timeless pursuit of peace and rest. A quirky tidbit that highlights the cutting edge of sleep science is research into targeted memory reactivation during sleep. Scientists are exploring ways to gently cue memories during specific sleep stages, e.g., by playing a sound associated with something you learned that day to enhance their consolidation. Imagine studying for an exam, then having your brain subtly reminded of key facts while you sleep, making them stick better. While still largely experimental, this research points to a future where sleep isn't just passive rest, but an active, programmable state for learning and memory enhancement. Beyond individual optimization, sleep science is also delving into broader questions, such as the evolutionary purpose of different sleep stages, the precise genetic basis for sleep disorders, and the intricate connections between sleep and neurodegenerative diseases. Researchers are using advanced brain imaging techniques to map the flow of cerebrospinal fluid during sleep, deepening our understanding of the lymphatic system's role in clearing brain waste products. This is leading to new therapeutic approaches for conditions like Alzheimer's and Parkinson's. You've explored the cutting edge of sleep science. Now, as our journey through the evolution of sleep draws to a close, let's bring it full circle, back to your very own bedroom, and reflect on the profound importance of reclaiming rest in the modern world. This is a mainstream wellness fact. Despite technological advancements and societal pressures, prioritizing sufficient, quality sleep remains one of the most fundamental and impactful actions you can take for your overall health and well-being. You can almost feel the gentle invitation of your own bed, a sanctuary of peace in a constantly buzzing world. Imagine, for a moment, the relentless pace of modern life in Musashi Murayama, Tokyo, Japan, or wherever you are right now. The 24/7 economy, the constant digital connectivity, the sheer volume of information vying for your attention, all these forces conspire to erode your precious hours of rest. You've seen how our ancestors' sleep was dictated by the sun and survival, how the Industrial Revolution extended the day, and how the electronic age has blurred the lines between wakefulness and slumber. Now, it's about consciously choosing to reverse some of those trends. It's like finding a quiet, ancient path through a chaotic, brightly lit modern city, guiding you back to a more natural rhythm. Historians and public health experts still argue about the long-term societal consequences of chronic sleep deprivation on productivity, mental health crises, and overall public safety. Will societies eventually be forced to reevaluate their relentless pace and prioritize rest more broadly? Or will individuals continue to bear the brunt of insufficient sleep? Regardless, the personal power to reclaim your rest is profound. It's an investment in your memory, your immune system, your mood, and your physical vitality. As you finally drift off tonight, remember the long, incredible journey of sleep through evolution and how, in this very moment, you are consciously choosing to embrace one of humanity's most ancient and essential acts of self-care. As the echoes of ancient slumbers and modern science gently fade, feel your own consciousness soften and expand. The journey through sleep's evolution has shown us its universal embrace, its profound adaptations across species, and its non-negotiable importance for every facet of your being. From the half-awake fish to the dreaming human, from the communal cave to your quiet room, sleep connects us all, a timeless rhythm of renewal. Let the insight settle, knowing that as you surrender to this nightly embrace, your body and mind are performing miracles of repair, memory, and rejuvenation. Allow yourself to be cradled by the profound peace that comes with rest, letting go of the day's demands and anxieties. All the knowledge has been shared, all the stories told. Now, simply rest. Let the stillness guide you deeper into peaceful dreams.